Are these triangles similar? Are these triangles congruent? Yes, no, not enough information. Yes, no, not enough information. Okay, so how do we do these? These are important questions. Number one, every triangle holds 180 degrees. Step two, across from, well here, let me make it smaller and simpler. Smallest angle is across from smallest side. Medium is across from medium, and large is across from large. Meaning, like when you open an angle, say I have a really small angle, or that's going to affect, the bigger you open it, the more it'll affect the side across from it. If you open that angle up really big, like that, it's going to make the side across from it get really big. An angle affects the side across from it. So that's where we get the idea that the smallest angle is across from the smallest side, medium from medium, large from large. Okay, so what does that mean? Well, if this is 3 and this is 3, they're the same side length in the same triangle. So across from that 3 is 65, then across from that 3 has to be the same thing. That has to be 65 degrees as well. If you have two sides that are the same, the angles across from them must be the same. And then if we have 65 and 65, we can find the last angle by subtracting from 180, right? 180 minus 65 minus 65. What's that going to be? 50? So this one's 50. That makes 180 total in that triangle. Okay. So now, what do we know in this situation? Are these triangles similar? What does it take to be similar? You got to have two of the same angles. Because if you have two angles the same, thus you have all three, right? Because there's only 180 total. So if you know two angles are the same, then the third one has the same amount left over in both cases, then all three have to be the same. And if you have all three, AAA, that proves the two triangles are similar. Similar means same shape. Same shape could be different sizes, right? That's what similar means. Whereas congruent means identical, totally the same. So similar, same shape, but they could be different sizes. And how you prove similarities, you got to have two angles that are the same, which implies all three are the same, which is enough to prove that they're similar. Well, do we know that? What do we know? I know two 65s and a 50. Over here I know a 50. And that's all I know. I don't have any idea of the other two angles. I just don't know. They could be anything that makes the total, right? They could be all kinds of things. So I do not know. They might both be 65, and in that case, these triangles are similar. But one of them might be 60 and the other one be 70. I just don't know. So not enough information. There's just not enough information there to decide. We can't know that. Now, you might say, well, yeah, well, that means same thing down here. Careful, careful. Just because you know they're not, you don't know about similarity, you might know something about identicalness. Could they be identical? You might say, well, yeah, you don't know if they're similar, so you don't know if they're identical. Well, careful. Notice this 3 is across from the 65. Right? 65 and 65 are the largest angles. So that's largest. So remember, across from the largest angle or the largest side, medium to medium, small to small. So this is the largest 3 must be the largest sides in this triangle because it's across from the two largest angles. The other one, the 50, this, whatever this side is, it must be smaller than 3. How do I know that? Because 50 is smaller than 65. So the smallest angle across from it is the smallest side. So 50 is a smaller angle than 65 and 65. So across from the 50, this side over here must be smaller than 3 because 3 is across from both of the 65s. Okay, so what? So across from the 50 is a side smaller than 3 in that triangle. What about in the other triangle? Across from the 50, I should say, is exactly 3. Is exactly 3. Over here, across from the 50 is smaller than 3. So they cannot be identical. No way. Right? It couldn't be. If they were really identical, then they would have to have the exact same sides across from the exact same angles. You must say, yeah, but these could be 65 and 65. They could be the same. Well, the angles could. Yeah, that's possible. But no way the sides are going to be. Why not? Because across from this 50 is something smaller than 3. We already proved because that's the smallest angle in that triangle. And across from this 50, we know we have exactly 3. Can't be something smaller than 3. So there's no way they can be identical. No way. We know that for sure. There is enough information to decide that. They are not identical because they do not have the same sides across from the same angles, even if they do have the same angles. They don't have that. Another way you could say it is this one has 3 across from 65. How about that? This one has 3 across from 65. This one has 3 across from 50. So no way they are identical.